Okay, so a few announcements. The homework 4.1 part 2, that's due today, and then 4.2 is due on Friday. Second exam will be available on D2L on April 10th, next Friday. You get 3 hours. The exam will be available all day, but you only have 3 hours um, to work on that. Make sure to check out the review checklist and the formula sheet that I posted on Piazza. You can also check out the past year exams on the website. Make sure to also check the changes to the grading scales. So basically, um, um, at the end of the semester, when you get your grades, you have the options to choose whether you want to
No.
input your grade as satisfactory or not satisfactory on your transcript. And then on top of that, for Math 132, there are two other alternative grading scales that you should look at. So both of them have more weights on the homework. So I remember one of them is 50% of the final grade, and the other one would be 40% of the final grade. Um, so yeah, as I mentioned, do your homework. It's basically 3 points if you do your homework. Um, any questions before we start? No questions? All right. So what did we do last time? We talked about, I guess we defined, what do I want to say? So we defined the integral. We define the integral of a function from a to b, or at least for a positive function. For positive functions, we define the integral of f of x from a to b to be the area under the graph of f of x from a to b. And then I mentioned that if you write this properly, it's the limit of the sum of this thing right here. Let me remind you again. So this f of xi, so for you have n points, and when you plug those into your function, what you get is actually the height of each rectangle. So for each xi, f of xi is the height of that particular rectangle. This thing here, it's the width of each rectangle. Yellow is not good. Let's do green. This is the width of the rectangle. So when you multiply the height by the width, you get, this is the area of one rectangle. And then when you take the summation, when you do the sigma notation, you're summing up all the areas. So what you get is the areas of n rectangles. And when you take the limit n goes to infinity, so that means you're taking infinitely many rectangles. So that gives you the exact area under the graph. Is it okay? Now, when you're doing your homework, the hardest part is actually to find the height and the width. We have done 2 examples last time, but I want to do one more today. Any other questions? Any questions before I move on to the next page? No? Okay. So let's look at this question. So this is what work 4.2. Yeah, 4.2. Question 6. Okay, so the question is to compute the integral of 2x minus 8 from 3 to 5. Using the formula that we just mentioned. So you want to find what is the function f of x, what are the sample points, and what your delta x should be. So let's do the delta x first. Oh, how do I? Let's do the delta x first. So how do I compute the width of the rectangle again? So assuming we're taking n rectangles, what is delta x? Okay, so the length of the interval is 5 minus 3. So 5 is the upper limit and 3 is the lower limit. And then you divide that by the number of rectangles, and you assume that we assume we're taking n rectangles. So delta x is 2 over n. Is it okay so far? So the second thing we want to do is to find the sample points xi. I goes from 1 to n. Let's start with x0. So what is the initial point? What is the starting point? 3. So x1 equals. By the way, the starting point should always be the lower limit. The lower limit is 3 here, as you can see from the integral. So x0 is 3. What about x1? What is the next point? No. Yep. You computed the width to be 2 over n. So x1 should be 3 plus 2 over n. x2. Yep. So add 2 copies of 2 over n to 3, so on and so forth. So xi would be 3 plus I copies of 2 over n. Is it okay? So 3 plus 2i over n. That's your xi. Questions? Is it okay? No, we're not done yet. So what is your function here? What is your f of x? From the integral, can someone tell me what is a function? F of x? Two x minus 8. Okay, and remember that remember this formula right here. So let me rewrite this. So remember that we have this formula. So I need to compute f of xi. Sorry, what I mean is for the first entry in your answer, we want to put in f of xi as well as delta x. So let me do the next page. F of x was 2x minus 8. That's what you have here. F of xi would be just plugging in the xi into your function. So you get 2 times your xi, which is 3 plus 2i over 8. You also need to multiply by delta x, but delta x is 2 over n. Questions? Yeah, I think I missed something. So 2 times xi minus 8. Over n, yes. Thank you. Is it okay? Let me say this again. So this is f of xi. I think I use orange. This is f of xi. This is delta x. Where did I get the 8? I want to plug this into this to get 2 times whatever that is minus 8. 2 times whatever that is minus 8. And then according to the formula, I also need to multiply by the width, which is 2 over n. Any questions before we go on? So that's the first entry that you're gonna put in. The second entry, it means that you want to simplify the summation. So let me do this for you. So how do I simplify that? So let's simplify whatever that's inside the summation. So multiply the two, distribute the two, you get 6 plus 4i over n minus 8 times 2 over n. And then you have 6 minus 8, which is negative 2. Times 2 over n. And then multiply everything out. So multiply, distribute a 2 over n inside the with parenthesis, you get -4/n plus 8i/n squared. Questions? Yep. By the way, you have two questions like this on the webbook, and this is the easier one. And I'll let you figure out the harder one. Questions? This would be a good time if you don't understand what this would be a good time to ask if you don't understand what I've done so far. No? Okay. All right. And we're not done yet. So we want to compute this summation here. And remember that one of the properties of the summation of the sigma notation is if you're adding two different stuff, then I can always split them into two sums. So I'm gonna write like this. This is my first summation, first sum. The second sum is something like this. No, that wasn't the second answer. Is it okay? That was the first. Well, yeah, you can put this into your first, or you can put this. Whichever one you like. It doesn't matter. Anyway, so I'm working on the second one. We haven't done yet. We're not done yet. Is it okay? This step. All right, so you have two summations. Let's do the first one. So what is the sum of -4/n and I goes from 1 to n? So first of all, does whatever that's inside this summation depend on the index I? No. So with respect to the index I, this is a constant. -4/n is a constant with respect to I. That means I can pull the constant out of the summation like this. And whatever that's left over is just 1. Make sense? Is it okay? For the second term, I want to take the sum of 8i divided by n squared. I goes from 1 to n. Again, 8/n squared doesn't depend on the index I. So I can pull out the 8/n squared, and I end up with something like this. Is it okay? And let's deal with the first one. What is the summation of 1 it doesn't depend on I because I goes to 1. Okay, when I say it doesn't depend on that, I mean when you change I, that doesn't change the value. So -4/n, so for example, for the first summation, you're taking the summation of -4/n, I goes from 1 to n. So when I equals 1, you get -4/n. When I equals 2, you get -4/n. When I equals 3, you get -4/n. It doesn't change when I changes. That's what I mean by it doesn't depend on n. And so for the second sum, 8/n², it also doesn't depend on I. And by one of the properties I mentioned, I don't know, last Friday, if it doesn't depend on I, you can always pull that out outside of this summation. Is it okay? Does it answer your question, Daniel? Okay, now let's do with the first sum. What is the sum of 1 when I goes from 1 to n? How many 1s do I have? I have n of them. So when I equals 1, I get 1. When I equals 2, I get 1. When I equals 3, I get 1. When I equals n, I get 1. So I have n of them. This is the first one. Second one, what is the sum of I? I goes from 1 to n. In other words, I'm asking what is 1 plus 2 plus 3 plus 4 plus all the way up to n? Nope. Okay. Seriously, guys? So from that, I can tell none of you have finished the homework yet. So this is from the formula that I mentioned for the sigma notation. The formula for this guy, still blue. The formula for that guy is n times n plus 1 divided by 2. Is it okay? Let me check the formula. I think this one is correct. Yep, that's correct. Questions? Okay. Okay, let's simplify this. So so before I take the limit n goes to infinity, let's simplify this. So -4/n times n, the two n's cancel out. So the first term is just -4. The second term, you get the top is 4 times n plus 1 divided by n squared. Questions? By the way, someone meant, yes. Wait a second. So I think someone mentioned that this one should be n factorial. So n factorial is actually n times n minus 1 times n minus 2 all the way down to 1. I think it's Ryan. Anyway, so yeah. So you can cancel out the n with one of the n. You get 4 times n plus 1 divided by n. And let's multiply everything out. So you get 4n plus 4 divided by n. Feels like I'm writing h, but this one should be n. Okay. And this one should be 4. No, okay, so I'm splitting 4n plus 4 divided by n into 2 terms. The first one is 4. The second one is 4 over n. Is that okay? These two cancel out, so you end up with just 4 over n. Make sense? Yeah, okay. And so whatever you saw here, I guess this one, this one, this one, this one, and this one, or this one, you can put either one of them into the second entry. And for the last one, for the last step, I want to compute the limit. What is the limit of 4 over n when n goes to infinity? Yeah, 0. So 0 is the last entry. Does it make sense? Okay. Questions? All right, so I want to finish up section 4.2 today. So the next thing I want to talk about is some properties of the integrals. So I'd say that for positive function f of x, the integral from a to b is the area under the graph from a to b. What if your f of x is positive somewhere and then negative somewhere else? So it would turn out that this is actually the area above axis minus the area below x. So maybe one example is like this. So what I'm saying is, if this is your f of x, then the integral of f of x from a to b would be orange, the area in the orange region, minus the area of the green region. That's the first property. Second property, I have two parts. So what do you think this is? If I'm taking the integral of f of x from a to the same point a, what do you think that's going to be? So I'm calculating the area under the graph of f of x from a to itself. Okay, so what does it look like? So no matter what f of x looks like, let's say this is your a. So yeah, that's what I'm explaining. So let's say this is your f of x. Let's say we want to compute the integral of f of x from a to a. So that means I want to calculate the area of this line. What is the area of a line? Does it have any width? No. So if it doesn't have any width, that means the width is 0. That means the area is that means the area should be, yep. So in general, if you have if your lower limit is the same as the upper limit, the integral is 0. Second thing is the integral of of f of x from a to b, it's actually related to b or b to a, but with a negative sign. So if you want to switch your lower and upper limits, you need to put in a negative sign. And then some other properties are the following. So if I want to take the integral of f plus or minus g, then I can split them into two terms. So I can calculate the integral separately and then plus or minus them. Second property, if I can calculating the constant multiple, the integral of a constant multiple, I can always pull out the constant. And then the next one, if a function f of x is smaller than g of x, then what can you say about the integral? So if one function is smaller than the other function, what can you say about the integrals? Again, integrals are areas. So which areas would be bigger? If the yeah, okay. So if f of x is smaller than g of x, then the area of f of x should be smaller than the area of g of x. That's because the height is lower. And so the area of each rectangle would be smaller as well. And then the last one, if I want to calculate the integral from a to c, I can do from a to b first, and then b to c. So for example, if I want to calculate the area from 0 to 5, I can first do 0 to 3, and then 3 to 5. That's what it's saying. Questions? Okay. Now let's look at this example. Suppose that the integral from 5 to 10 minus the integral from 5 to 15 is the same as the integral from a to b. Question is, what is a and what is b? So we're going to use the last property here. So that's saying that if I want to do the integral from a to c, that's the same as first doing a to b and then do b to c. Um, yeah. Why are they both a? Which one? Oh, did I say a? Sorry. So from, oh, in the question, we'll see. So that means it's actually not, it's not as straightforward as the formula, but it will be similar. We're gonna use that at some point. Okay. So let's do something to the left-hand side. So left-hand side, let me pull out a minus first. So if I pull out the minus, that means the second term becomes positive. And then the first term becomes negative. So I'm switching the two terms, and then the second term becomes positive. The second term, the first term becomes negative. Is it okay? So this is my left-hand side. Is it okay? And now let's focus on whatever that's inside the parenthesis. So the first integral you're doing from 5 to 15. You're calculating the area from 5 to 15, and then you want to subtract the area from 5 to 10. What do you end up with? 10 to 15. Good. Is it okay so far? All right, so the left-hand side equals negative the area from 10 to 15. If you have a negative sign, that means I can switch the two limits and the integral would become positive, right? That's what we mentioned here. If you want to switch the lower limit and the upper limit, you put a negative sign. So the question says that left-hand side equals the right-hand side. So A equals what? So A equals 15, B equals 10. Questions? Why is that? So I'm comparing this with this. They look almost the same, right? And the question says that they should be equal. And then I'm asking what is A and what is B. But then you have the upper limit is 10, the lower limit is 15. Okay. Any other questions? All right, so that was it for section 4.2. In the last 10 minutes, I want to start the next section, section 4.3. This would be the last section for the second exam. Section 4.3 is called the fundamental theorem of calculus. So what it tells you is, it tells you the connection between taking derivative and integration. Okay. So let me just put down a theorem. So there are two parts. I'm going to just mention the first part today. Fundamental theorem of calculus, part 1. Suppose that f of x is continuous on the closed interval from a to b. Consider the function g of x to be the integral of f from a to x. The theorem says that g of x, this function right here, is also continuous and it's also differentiable. And you can actually calculate the derivative. Anyone want to guess what the derivative should be? So g of x is the integral of the function f. What happens when you take the derivative of the integral? Let me say this again. G of x was defined to be the integral of the function f. I'm asking what happens when you take the derivative of the integral. Yep. So you know that taking integration is like reversing the process of taking derivative. So when you take the derivative of the integral, you should get back the original function f of x. Is it okay? Why do I have f of t? It's just a variable. I don't want to use x because I want to preserve the variable x for g, for the function g. Any other questions? Okay. So given g of x equals the integral of the square root of 1 plus t squared from 0 to x, find the derivative. So what is it? One plus t squared. So what is the derivative of this integral? Wait, what? Yeah, it would be just whatever that's inside the integral. And why is it? This is by what theorem again? Yeah, so basically it follows from what we just say. If you're taking the derivative of the integral, you will actually end up with whatever the function inside the integral. So this is by the fundamental theorem of calculus. Daniel, what is your question? Yeah. Yeah, so keep in mind that when you're taking the derivative of the integral, your answer should be something like the function inside the integral. Make sense? Okay. Let's do one more example. Actually, yeah. Yeah, let's do one more example, but I'm going to call this example the fundamental theorem of calculus plus chain rule. The question is compute the derivative of the integral from 1 to x4 secant of t. Now, before using the fundamental theorem of calculus, I'm going to define a different function first. So define g of x to be this function. And then I'm changing the upper limit to be just x. Is it okay? So instead of putting x to the 4, I'm putting x. And so the derivative of that, the derivative of the function, of the integral in the question, that's the same as asking what is the derivative of g of x to the 4? No. So that means, so we want to compute the derivative of g of x to the 4. Does everyone agree with this? Right. Well, we should be confused because if you're not, you're either too smart or you have no idea what's going on. Okay, so the first thing I did was I defined the function g of x to be almost the same as the integral, but instead of putting x to the 4, I put x, right? And I'm saying that the question to compute the derivative of that is the same as first you plug in x to the 4 for your x, and then you take the derivative. Do you see that? Because when you replace x by x to the 4, you also replace the upper limit by x to the 4. Yep. Yep. And so the derivative, how do we compute the derivative of g of x to the 4? This has to do with the chain rule. So the outside function would be g of x. The inner function would be x to the 4. But chain rule says that this is g prime. So you take the derivative of g prime. You take the derivative of g, and then you're plugging x to the 4 multiply by the derivative of the inner function, which is x to the 4. This is by chain rule. And then the derivative of g, the g function was defined to be the integral. So by the fundamental theorem of calculus, g prime would be the derivative of that, which is just the secant function, right? Because that's inside the integral. But then it's not exactly that. From chain rule, we know that we need to plug in x to the 4. So you need to replace the t by x to the 4. Should I say this again? Okay. Okay, let me start over. Okay, let's go back to the function g of x. So g of x was defined to be the integral from 1 to x. And so by fundamental theorem of calculus, we know that g prime of x, so the derivative of g of x, should be secant of x, right? So whatever that's inside the secant, whatever that's inside the integral, it will be the answer. And then you replace the t by x. Is that okay so far? And then we want to go back to compute this guy. So the derivative of g of x to the 4. First step, by chain rule, I know that this is g prime of x to the 4 times x to the 4, the derivative of that. And then the second term is easy. So what is the derivative of x to the 4? It's just 4 times x cubed, right? The hardest part is the first part. So I know that g prime of x is secant of x. What is g prime of x to the 4? I know that g prime of x is secant of x. So g prime of x to the 4 should be secant of x to the 4. Make sense? Questions? Okay, I need one more minute before I let you go. Give me 1 minute.